Hello again. Let's talk about a little something that we like to call vsepr. vsepr is the valence shell electron pair repulsion theory. Essentially, what this does is it gives us a way to understand the shapes of different molecules. Okay, I'm going to let you read through this on your own. Go ahead and read through that, and then we're going to take a look at these examples so that we can tell what kind of shapes we have. So I am going to quickly draw the Lewis dot structures for these. I'm going to assume that by now y'all know how to draw the Lewis dot structures on your own. If you don't, come on into tutoring and we'll get that figured out together. But for right now, I want us to mainly focus on understanding the vsepr shapes. Okay, so right now, like I said, I'm going to assume that you already know how to do the Lewis dot structures. So number of bonded atoms on my central atom, I've got 2 chlorines. So those, I've got 2 there. Number of unshared pairs of electrons on my central atom, I have none. So that makes my ABX structure AB2. Okay, now what AB2 tells me is that's going to tell me what type of shape I have. Okay, so the type of shape that I have, this is going to be a linear molecule. Okay, that's the name of my shape. Every single AB2 is going to be linear. So let me show you an AB2 atom. So here's your A, which is your central atom. The B2 is, excuse me, that's your peripheral atoms. And then the fact that we don't have an X shows that we do not have any peripheral, or excuse me, any unshared pairs of electrons. So here goes a linear atom right here. Okay, so that's that. Let's go ahead and now take a look at the next one, which is BF3. Like I said, I'm going to quickly draw the Lewis dot structure for this. I don't want to spend a whole lot of time doing that. Fill in your electrons around that. So now I've got 3 bonded atoms on my central atom and no unshared pairs, giving me AB3. Okay, anytime that you have AB3, that is going to be the shape of a AB3 molecule is going to be trigonal planar. Trigonal planar. Okay, so let's go ahead and take a look at a trigonal planar molecule. So here's an example of a, oh, that's not a trigonal planar. Here's an example of a trigonal planar molecule. Okay, notice how the trigonal portion comes from the fact that there's 3 peripheral atoms, and the fact that it's planar, if you notice, they're all within the same plane. Okay, so that's going to be a trigonal planar molecule. Every single AB3 molecule is a trigonal planar molecule. Let's look at the next one here. We have SiH4. Here's our Lewis dot for SiH4. Okay, so I have 4 atoms bonded to my central. I have no unshared pairs, so this is going to be an AB4. A meaning that there's 1 central atom, B4 meaning that there's 4 peripheral atoms, and then the fact that there's not an X tells me that there's no unshared pairs on my central atom. Okay, this is going to be a shape called tetrahedral. Tetrahedral. Let's take a look at a tetrahedral molecule. An example of a tetrahedral would be like this little fella right here. It's going to look just like this, okay? So you've got your central atom with the 4 peripheral atoms around it, and it kind of looks like a little pyramid sort of deal. That is a trigonal, that is a tetrahedral molecule. Let's take a look at our next one, which is pH3. Our Lewis dot for pH3 is going to look like this. And we actually do have an unshared pair on this one. So I've got 3 atoms bonded to my central. I've got 1 unshared pair, making this an AB3X. Okay, the name of this shape is going to be called trigonal pyramidal. Okay, trigonal pyramidal. This one really does look like a little pyramid. Okay, and let's take a look at what a trigonal pyramidal molecule looks like. Uh-oh. Uh-oh, uh-oh, uh-oh. Do I not have trigonal pyramidal? Womp womp. Trigonal bipyramidal. That's not what I'm looking for. Come on. Oh, Nope, that's not it either. Nope. Let me see here. Nope. Let me see if I can find one. Here we go. Here's one of my little trigonal pyramidal friends, okay? So notice we've got an unshared pair of electrons on top here. So that's what this one is representing as well. This purple atom here in the middle, that's your central, and it's assumed that there's an unshared pair on top, okay? That unshared pair is causing this to go from that trigonal planar model. It's actually repulsing, hence the valence shell electron pair repulsion theory, okay? So it's actually pushing those other atoms down to where it's giving it that pyramid-like shape. Okay, let's take a look at the next one, H2O. This one is a very important one. So I've got H, O, H, and unshared pair, unshared pair. Okay, so now I've got two atoms bonded to the central and two unshared pairs, giving me an AB2X2 shape. Okay, anytime and every time that you have AB2X2, it's going to give you a bent molecule. So let's take a look at what a bent molecule looks like. Here's a bent molecule here. Notice you've got your two unshared pairs. So instead of this being linear, it's literally bent down, okay? Because it's assumed that I've got unshared pairs of electrons here and here, which are forcing these other atoms to go in a downward shape, okay? So here would be one here, and here would be one here, okay? That's going to be a bent molecule. Anytime and every time that you have AB2X2, it's always going to give you a bent shape. Let's look at the next one, ASBR5. Okay, this is an expanded octet one where you've got we have to put extra electrons on the central atom. And we actually form a bond. Okay, now I do want you to go ahead and put all your dots around bromine. The only reason that I'm not is to save time on the video. We have 5 atoms bonded to our central atom. We have 0 unshared pairs, and this is going to give us an AB5 structure because I have 1 central, 5 peripherals, okay? This is going to give me the shape of trigonal bipyramidal. Trigonal bipyramidal. Let's take a look at what a trigonal bipyramidal molecule looks like. Here goes a trigonal bipyramidal right here. So notice this one is actually a combination of trigonal planar and linear. Okay, we put a trigonal planar and a linear together. Oh, you see, if I got it like that, it's like, oh, wait, what do we got here? Okay, and then, oh, boom, it was hiding. Okay, so this would be a trigonal bipyramidal molecule here. Okay, you can kind of see the trigonal planar look right here in the middle with a linear going straight through it. Okay, so that is a trigonal bipyramidal. Okay, we have one more shape to look at. The example is SEF6. Okay, so I've got 6 fluorines around a selenium. Okay, obviously this is another one of our expanded octet situations. Okay, I've got 6. Nope. Yep, I've got 6 atoms bonded to the central. I've got no unshared pairs. So since I've got 1 central atom, it's just 1A. I've got 6 peripherals, so that's B6. I have no unshared pairs, so I don't get an X. And this shape is going to be called octahedral. Octahedral. Okay, so let's take a look at an octahedral. Blah, 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 blah. Here we go, octahedral. And there's my octahedral shape. Okay, I've got my central. I've got 6 peripheral atoms around it. And there we have it. Okay, that's how she do right there. So, yeah, octahedral. Now, as you can tell also, there are some other shapes, okay? Square planar, kind of one of my favorites, okay? But we don't talk about square planar. So there are some out there that you don't have to know about. Just know that these are not the only shapes, okay? Here goes a square pyramidal right here, okay? Doesn't that look fun? Okay, I think that looks super fun. Let's see here. What are some other ones? Linear. Oh, the T shape. Okay, we can't forget about Mr. T shape. And then there's a seesaw one as well. This is the other one I wanted to show you. Okay, here goes the seesaw. Okay, yeah. So either way, long story short, are there other shapes? Yes. The only ones that you need to be aware of are the ones right here on your chart. And remember, the way that you tell what the way that you tell what kind of shape it's going to be is all based on the ABX structure. Okay. Lastly, the general polarity of the shape is based on the fact of do we have an X or not. Okay. If we don't have an X, then it's considered nonpolar. Okay. So this one doesn't have an X, so it's non. This one doesn't have an X, so it's non. Okay. Anytime you do have an X, it is polar. Okay. So AB3X, this one is going to be generally polar. Okay. So I'm going to let you fill those in based on if there's an X present or not. Okay. We're going to practice this more in class. Have a wonderful time.